Hello and welcome to week 8 of CS103 Machines, Languages and Computation. So the first thing that I need to remind you about is that there is another class test coming up for you, the second class test of this semester, and it's set for Friday the 4th of December. That's the Friday of week 11. And it'll be in the same format as the first one. Test paper will be released at 8 in the morning. You'll upload your solution document by 8 PM that same day, so you've got 12 hours in total. It counts for 25% of your mark for the class, and there are 5 questions on the test, and you do all of the questions, and you should attempt every question because only a blank space gets 0. This time, the 5 questions are going to be on these topics. The first question will in fact be on infinite sets and non-computable functions. We haven't quite finished that topic. I still need to provide you with that proof, and I'm going to do that for you this week as the first thing that we do. Then the second question is on grammars and recursion. That's on the material that we covered last week with our silly sentences grammars and making the recursion produce more than one adjective, as many adjectives as we like, things like that. The third question is going to be on grammars and regular expressions. That's the material that I'm going to present to you this week. And it's about basically characterizing languages as sets of strings and using these devices called regular expressions to characterize the language that we get. You'll see it when we come to it this week. Then question 4 is about recursion in logical definitions. Sometimes it's possible to define logically things in terms of themselves when you're creating a logical definition. Let's say you've got 2 points on a railway line, and you're trying to define if a certain station has a connection to another station. Well, the one way that you can do it is by saying a station is connected to another station if the first station is connected directly to an intermediate station, and then that intermediate station is somehow connected to the destination. So in other words, take 8 stations A and B. So is A connected to B? Well, let's see if A is connected to some station, call it C, somewhere along the line. And then if C is connected to B, then we know that there's a connection between A and B. We'll see how this works when we come to it. Finally, recursion in function definitions. I've shown you this a little bit already. It's possible to define functions in Python and in other languages as well. I'll show you how to do it in Python. By using recursion, you can define a function, say a function to count the number of elements in a list. You can define that in terms of itself, and we'll see how that comes. So there's the 5 questions. 4 of them are recursion. Basically questions 2 to 5 are all on recursion, and then the first question is about these infinite sets and non-computable functions that I'm going to tell you about this week. So this week we will be looking at non-computable functions, and I'm going to finally give you the proof that some functions that you might like to compute, you can't compute at all. I'm going to consider functions that take as input a natural number, 0, 1, 2, 3, 4, etc., all the way up to infinity, and as output produce a natural number. So we call those the functions from the natural numbers to the natural numbers. I'll consider all those functions, and I will prove to you by using a proof by contradiction that some of them have no computer program associated with them. So in other words, they're non-computable. Then I'm going to go on to grammars, which are also infinite, if you're using recursion and you've got infinite structures. So it kind of ties in with the infinite sets that we're looking at in the proofs. I'm going to first give you a recap of the languages and grammars. If you listened to me last week on Friday, it's the same stuff, so you can probably skip over that. But I thought I'd put it into the normal form. Finally, we're going to look at languages as sets of strings. So we're not thinking of them as sequences of words. We're thinking of sets of strings. Things like A, B, B, A. That's a string. A, B, 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 A. That's another string. The question is, can we characterize infinite sets of strings that have a certain structure using our grammars? And then can we describe them using these devices called regular expressions? Regular expressions are very, very useful. We use them a lot. We're going to use them here basically to say how certain things repeat. So that's it. It's going to be a fairly hectic week, but I hope you enjoy it. So I'll see you in the next video.